Hello and welcome. Today we're going to be looking at quadratic and exponential word problems. As always, we're going to be looking at 5 problems that are explanations so that we can find the intricacies in this topic so that you can ace the SAT math portion. We're still in the Passport to Advanced Mathematics section, having finished the heart of algebra. And if you like these videos or found them informative, please be sure to like and subscribe. With that, let's get on to our first question. Question number 1 is the width of a rectangular box is 2 centimeters less than its length. The height of the box is 8 centimeters. If the box has a length of x centimeters, which of the following functions represents the surface area x in square centimeters? Well, how are we going to approach this question? Well, the box is a length of x centimeters, right? So the length equals x centimeters. And we're told that the width is 2 centimeters less than the length. So the width is the length minus 2, so that's x minus 2. And the height is 8. Right? Now we're trying to find the surface area S of the box. Well, surface area, right? So we need to find each of the surfaces, the area of each of the surfaces, and then add them together. Right? So there are 2 surfaces where you have the length and the width as a rectangle. There are 2 surfaces where you have the length and the height. There are 2 surfaces where you have the width and the height. So all we really need to do is multiply these two, and these two, and then add those 3 together. So LW, well, that's going to equal x squared minus 2x. And then LH is going, LH is going to equal 8x. Now, where is that one? WH is going to equal 8x minus 16. So we add that all together and we get x squared plus 14x minus 16. And then we have to double that because there are 2 surfaces for each of these. All 3 of these, there are 2 surfaces that have that. So we double that to get 2x squared plus 28x minus 32, which is choice B right there. And let's move on. All right, question number 2, and it is a forest ranger travels up a river by boat to collect soil samples. The boat travels at a speed of v miles per hour for a distance of 2 miles. After collecting the samples, the ranger travels the same distance back, but the boat travels 5 miles per hour slower than it did on the way up the river. If the ranger spent 3 hours traveling up and back, which of the following equations can be used to determine the speed of the boat on the way up the river? Let's see what we can do here. Well, the going up, right? We have 2 miles at v miles per hour. That's going to be 2 over v, right? And then coming back, we have 2 over v minus 5 miles per hour. And that gives us total hours, which is 3. And now we can multiply by v and v minus 5 to both sides, and we get v minus 5 equals 2 minus 5 plus. And now we just have to simplify this. We get 3v squared minus 15v over v minus 10. 4v minus 10. And then we switch things over. We get 3v squared minus 9 plus. And that is our answer, 3v squared minus 19v plus 10. The solution to v for this question is going to be the initial speed of v miles per hour. And our answer is then going to be choice D. Let's move on. All right, question number 3. For a particular delivery, a courier travels by bicycle at a speed of v miles per hour for a distance of 1.3 miles. After making the delivery, the courier travels the same distance back, but travels 2 miles per hour faster than on the way to delivery. If the courier spent 0.2 hours traveling to and from the delivery, which the following equations can be used to determine the speed of the bicycle on the way to the delivery. The speed of the bicycle on the way to the delivery was just a v. So we just need to find v. We can do the same process as last time. So we have 1.3 miles over v plus the 1.3 miles over v plus 2 because we sped up. And that's going to equal 0.2 hours. And multiply out by v and v plus 2. And what we get, well, we end up with 0.2 v squared, and then 0.4 v, which is technically the right-hand side right here. And that's going to be equal to 2.6 v plus 2.6. We subtract 2.6 v to both sides, and we end up with, it's going to be 0.2 v squared minus 2.2 v minus 2.6, which is answer choice A. All right, and that question is over. Let's keep going. All right, question number 4. The present value of an investment is the amount that should be invested today at a specified interest rate in order to earn a certain amount at a future date. The amount desired is called the future value. Approximately how much should be invested today in a savings account that earns 3% interest compounded annually in order to have $500 in 2 years? Well, you start at, say, x. Start at x. And you compound that once to get 1.03x after a year. And then the second time you get 1.03 squared x. And that's after 2 years compounded annually, so that's you're gonna have $500 at that point. So we just take our calculator, that's calculator active, right? You see the icon, and then you get 500 divided by the 1.03 squared, and we get our initial value to put in as $471, or choice B, and that is our answer. Let's move on. And here we are. A tritium, radioactive isotope of hydrogen, is often used in emergency exit signs. Because of the radioactive substance present in these signs, proper disposal is a matter of concern for the Environmental Protection Agency. The half-life of tritium is approximately 12 years. That is, every 12 years, the amount of tritium decreases by 50%. If the new tritium exit sign contains 25 curies, which I'm supposing is some unit, approximately how many curies of tritium will remain after 24 years? Well, after 12 years, you're going to have half of 25. And after another 12 years, 24 years, you're going to have half of that half of the initial 25. So that's going to be 1/4 of 25, which is 6.25 curies. So your answer is simply going to be 6.25 curies, and we are done. All right, so this unit was mainly about simply being able to interpret what the question was saying, being able to write equations based on that, just as we did in the heart of algebra, and then being able to manipulate these equations algebraically to get what we want. That is it for this. Make sure to tune next time when we continue our study of the Passport to Advanced Mathematics, and I'll see you later.